Hello everyone. Welcome to our channel. Today is 2025, April 12th. Today, we are recording the third video about Math Olympiad questions. So this is a very interesting question. The statement is following: if x and y are positive integers, and we also know x plus x times y plus y is equal to 76, and what is x plus y? So in this question, some other student already write the answer, and here I'm trying to review the answer and also trying to simplify the question, simpler answers. As you can see, his idea is turning these equations to be like x plus 1 times y times 1, y plus 1. And then we are trying to discuss case by case. There are 4 cases. And this proof is quite longer. And one idea to make it shorter is doing the following thing. We can observe that using a symmetric property, we can observe that x plus xy is a symmetric equation. Okay. Because if you swap x and y, you get the same thing. And similarly, the final answer we care, x plus y is also a symmetric equation. Okay. Therefore, we can say without loss of generality, we can actually assume x is less than 1 and at most y. Basically, x is less than y. Okay. And now let us compile and read this sentence. Okay. We can observe that x plus xy plus y is a symmetric equation. Similarly, the final answer we care, x plus y, is also a symmetric equation. Thus, we can say without loss of generality, we can assume 1 less than equal to x and less than equal to y. So therefore, we can keep the same proof as before, and we have this equation, and we add the plus 1, and then we get this one. Okay, so that's the major idea, and then we can get x plus 1 times y plus 1 is equal to 77. Okay, so let me see here if he's writing something too complicated, and maybe you can try to shorten it. Okay, let me think how to make it simple. So basically, the first sentence we can say recall the statement, okay, which is x plus xy plus y is equal to 76, right? And now let us adding the 1 on both sides of the above equation, okay? And then we get this, okay? And further, the above equation is equivalent to, for the left hand side, it trivially becomes x plus 1 times y plus 1 and equal to 77, okay? And therefore, we can actually remove a lot of calculations, okay? And then we can say we know 77 can be written as 1 times 77 and 7 times 11, because we can actually drop other cases we know, like x less than y, right? We can ignore 2 other cases because x less than y, okay? And therefore, for the first case, which is x plus 1 equal to 1 and y plus 1 equal to 77, and this case is invalid, that's correct. And for the second case, we can actually ignore, because due to symmetric property, we only consider one case. Okay, let me just remove it. And then we look at the third case, and which is become 1 plus x plus 7 and y plus, this is a feasible case, and the fourth case also can drop. So therefore, like the case 3 becomes case 2. And here, as you can see, we actually never write down what is x and y. We just need x plus y. Therefore, like once we have x plus 1 and y plus 1, we'll get the final solution. And also, you probably can consider like a -7 and -11. That's also the case we don't care, because we know x is positive. That's something we should also discuss in the future. So basically, there are 8 cases, and so let me write down. So essentially, there are 8 cases, as you can see, because you have like a 1. If you ignore a symmetric case, so let me write this way. So we know originally it has 8 cases, but if we assume then it becomes 4 cases. We also need to consider like a -77 times -1 maybe, and -11 times -7. This is also could be the case. However, now since x is bigger than 1, y bigger than 1, then we can also ignore the cases these 2. Thus, we only need to consider the following 2 cases. Okay, let me recompile, and now I think the proof is going to complete this time. Feel free to leave any question in the comment of video, and we will try to make more interesting video in the future. And have a good day.